Hello, we are from K9. Today we want to discuss about application of Cramer's rule. My name is Nafazila binti Zanurin. I want to talk about functions of Cramer's rule. First, help to solve any linear system of constant coefficient equations. Second, enable to find the transfer function of a transistor amplifier. Third, efficient for solving small systems and can be calculated quite quickly.
Okay, next, my name is Shashan Suhabin Teacher Azima, and today I would like to discuss about how to use Cramer's rule. Based on the theorem given of Cramer's rule, if A is a non-singular coefficient matrix for a system of linear equations, Ax equal to B, that is like the figure below, then the unique solution for the system is given by xi equal to determinant ai over determinant A, where I equal to 1, 2, 3, and the letters. And AI is the matrix obtained by replacing the ith column in A with the column B. Note that, first, Cramer's rule can only be used for systems where the coefficient matrix is non-singular. Second, if determinant A equal to 0, then the system of linear equations does not have a unique solution, and hence, Cramer's rule cannot be applied. Third, for homogeneous systems of linear equations, it is obvious that if the system has a unique solution, then determinant AI equal to 0 for all values of I. Hence, xi equal to 0 for all values of I, resulting in the trivial solution alone.
Okay, next, my name is Noifa Natasha binti Muhammad Shagawi. I'm going to talk about advantage and disadvantage of Cramer's rule. First advantage, we can find the value of x, y, or z without having to know any of other values of x, y, or z. If any of the values of x, y, or z is our fractions, we do not have to plug in a fraction to find the other values. Each value can be found independently, and also easy to remember step. Next disadvantage, computationally intensive compared to other methods. The most efficient way of calculating the determinant of n multiply n matrix via n minus 1 multiply n factorial operations. Second round of error may become significant on large problems with high integer coefficients. If the value of d is 0, then Cramer's rule will not work because we cannot divide by 0. However, if the value of d is 0, then we know that the solution is either no solution or infinite solution. We will have to use a different technique to find out whether the answer is no solution or infinite solutions.
So my name is Lokita Katyani Subramaniam, and today I'm going to talk about the applications of Cramer's rule in real world problem. So in this example, we are talking about a textile industry which sells three brands B1, B2 and B3 of yarn, where each of which is blend of Pakistani, Egyptian and American cottons with respective ratios. So we are going to, if the cost per kg of B1, B2 and B3 is rupees 40, 50 and 60 respectively, we are going to find the cost per kg of cotton for each country. So first of all, based on the given ratios, we group into each brands for B1, B2 and B3. For example, for B1, we have one of Pakistani cotton, two of Egyptian cotton and one of American cotton. So we let X, Y and Z be the cost per kg of Pakistani, Egyptian and American cotton respectively, and then we build the following system of equation. Since there are four ratio of cotton, so we are dividing it into 4, and then this system is built. Next, we simplify the equation by eliminating the denominator, eliminating the fraction, and we get this equation as stated here. So after that, we write it in matrix form, which is this as shown here. And since this matrix form is in the form of Ax equal to B, where A is the given matrix, X is X, Y, Z, and B are these values. Then we use the Cramer's rule. Since there are three solutions that we are about to find, which is X, Y, and Z, we will have to build three different matrices, which is A1, A2, and A3. So for A1, we substitute the value of B into the first column. For A2, we substitute it into the second column. and for A3 we substitute it into the third column. So based on those four metrics that we have, which is A, A1, A2 and A3, we find the determinant for each matrix using cofactor expansion as shown here, and therefore we get the determinant where determinant of A equal to -2, A1 is equal to negative 120, A2 is negative 40 and A3 is negative 120. So since we already get all the determinants, we use Cramer's rule to find out the solutions for x, y and z, where the formula is determinant of a1 over a for x, and we repeat the same steps by using a2 for y and a3 for z. Then we get the solution where x, y, z is equal to 60, 20 and 60 rupees for each grams of cotton. Thank you.